Now another property. It was this one was the second. Now about the third one. In case we multiply two radians together, like third rule, if we have m n a, so in that case we multiplied m n a. For example, if I have nothing, means that 2 multiply square root, the square root is a cubic root of 7 to 9. We say is equal to what? Is equal to 2 by, this is 2, so it's equal to 6, okay, 6 or 6th root of 729. Okay, dear? That's the fourth one. How about rule number 4? If we have nth root of a, and directly we will say we have a, and I will mix or collect with the fifth one that he say the same. He says equal to an. In this case, if you have odd, means that n be odd. Odd means that like 3, 5, 7, and this one will be the absolute value of n when a is even, means that 2 or square root, 4, fourth root, 6th root, and go on. Okay, now example, we will apply this rule number 4 and 5, fifth for what? The fourth and fifth rule for number. For example, if I have 3 to power 5 to the fifth root, I would directly say this exponent and this, they are equal, so directly I'll get a. See, here is 3. Now how about, for example, x to power 6 with the 6th, I say is equal to absolute value of 6, or just directly use write x as usual. Now I'm going to clarify example 8 in your page 15. Let's write a, part A. If you have what? If you have 3x to power 4, we will try to find because this is greater than this one, we will try to factor this x as xx. So we have a 4. I will write down 4 by 1. Why by 4 by 1? Because I know 4 by 1 is equal to 4. Why will change it to 4 by 1? Why will we wouldn't change to the 2 by 2? Because here's I have a cubic root. I want to distinguish, separate x to power 3 cubic x. That's why. So in that case, we will use the first rule for or properties of exponent, or sorry, radial or roots. So I have x to power 3. Now by the fourth one, I will get what? X, and it remains cubic root of x. That's all that you have in the example A, part A. For part B, as I did it for you a little bit, steps for you, a few steps. So in that case, how we deal with that one? First of all, we will separate it by the first rule. So for fourth root of x to power 8, fourth root of y to power 4. Now, this is the number, and we did it by the calculator or by hands. We use the factor. So I got 3, if you remember. And I will change this one later. But you know, this is the fourth root, so it remains absolute value of y, or just write down y. And I will separate this one to x to power 4, x to power 4. Why x to power 4, x to power 4? Because I have fourth root. And again, be like that, we will separate x to power 4 with the x to power 4. And again is going on. So I will get y, this one absolute value of x and absolute value of x. And if we multiply x by x, I will get what? I will get x to power 2 or x square. We remove the absolute value because the absolute value means that if this one is negative, I'll change it to the positive. But x square also, the squares means that. So that's why I say please remove this one. Just write down for me yx square. This is simpler for you. Okay. What's the next? Before I'm going to anything else, before I'm going to example 9, I'm reminding you as a note, as a homework, as a quiz, as assignment, as anything else, please try to solve these examples all. So because in the assignment I'll send you, or in the exam I will give you some result like that. Okay, dear? So, do not forget about 55 and 57. They are very important, and try to do it as much as you can. Okay. Now, example 9 is say which is one of the most important things here is dealing with what? With two different square root and sum between two of them. This means combine. Combine means that addition and subtraction between two roots or two radicals, radical or root. Okay, so combine means that addition and subtraction between them. So how we deal with that one, how we get these results, is very important, because this is the application of those rule. That's why I say important. Okay, now in the example 9, page 15, part A, say that combine 32 plus 200. So how we do this one? That's why I say sometimes you need what? Sometimes you need really hands or mathematics method. Okay, why? Because you need a factor here. It's easier for you. So because it's even, the last digit, I will divide it by what? I will divide it by 2. Why we need this one? Because we cannot say is equal to 232. As common mistake, do not do that, because there is no rule here. There is no rule here that say addition between what? Between roots. Where's addition? This is a multiplication, division, multiplication rule, nothing else. So you have no rules to say that. So how can we say is equal to that one? That's why do not do this common mistake. Okay, please, this is an error, so be careful. So that's why we need something unique. For example, if something here should be another thing here, then we can take a common. Okay, without that we cannot do anything. When I say square, I mean some number. When I say triangle, I mean the same number. That's what. So after this, solving this one, you know what I mean. So pay attention with me and be careful. So we divide by 2, I get 16, as you know. And again, it's even. We will divide it. I will get 8 divided 4 divided 2 divided 1. Now I got what? I got this number. And again, we will factor or shitalicking and factor of 200. So I get what? As I told you, do it by 5. Why by 5? Because you have a 0. The last digit is 0. So you can divide by 2 or by what? By 5. Let me do it by, I will do it by 2 because I have some idea. That's why I will do it by that. So you have 100 by 2, 15 by 2, 25. Now it's time for, because you have a 5, you should divide by 5. So 5, 5, 1. Now, because we have square root, so I'll choose between two numbers, just one, and I will choose this one by 2. As I told you before, this one it will be remains. Remains means that under the square root. So I have 2 multiply 2 and square root of 2. This one is equal to what? This one is equal to 32. Okay. Now, how about this one? From these two, I'll choose one. from that 2 I will choose 1, and this one will be remain. So means that 200 is equal to 2 5 square root of 2. So now is equal to 2 by 2 4 square root of 2. How about this one? This one is equal to 10 square root of 2. That's it that I say I need something here should be here. Okay, and should be the other, should be the same. If this 3, both these number to be the 3 to the p and the same. If it's a 5 or 3 4, it's okay. Here should be the same. Then I can take a comma. So now this one change it to 32 plus 200 under the square root as a radical. Change it to 4 square root 2, and also change it to 10 square root of 2. And you know this is the common, and there is equal to here. That's why I can say I can took square root as a common. Okay, and it remains 4 plus 10 is equal to 14 square root of 2. That's your solution here, and you can see the steps. Okay, and then I clarified all the steps for you. Now you should solve this one for me as a homework. By the same step, do it. Or it's okay, I'll do it for you. Now I have 25b, and there's a cubic of b. So square root of b cube. So how we solve this one? Because by the first rule, we will separate these, and there's minus, and again I wanna 2 by 1. Why 2 by 1? Because I have a square root. That's why I should separate 2 as we did it before for the here for the fourth. That's it, for the 3 by 1. Okay, the example 8. Now this one is equal to 5. This remains. How about this one? 2 by 2 is removed, just remains 1 by the you can see by the first or by the fourth rule, sorry, and remains this one. Now this one's the common between them, and I'll take the now this is the important example, and try to solve 29 and 33. That's all I need from you. Now we are near to finish. Just remains 2 pages, sorry. So try to be with me. In here we have a second part, we have a radical. All these rules, when I say all these rules, I mean from 1 to 7 of the positive or of the integer, and also from 1 to the 5 rule, law or properties, 1 to the 5 of radical. Okay, combine all of them or use all of them with just a little bit idea with just this definition. Okay, use the from the first to the 7th law of the radical of the exponent, and try to use from the first and to the 5th law of the radical or the roots now, and plus this property or that properties. Then you can solve from 10, 11, 12, which they are very important, till the last one. So that's why I say math is a chain. You should focus, or you should understand the first step, because the second depends on the first, the third depends on the first and the second. That's why I said nested information for you. So here I'm going to clarify this rule. Rational exponent with the rational exponent is the part B of, because the first part was the integer exponent. Now here I'm going to clarify this one for you. In this rule, pay attention with me. You have what? You see that if you have AMN is equal to ANM, careful. the denominator sorry, will be the roots. That's all that we have. The denominator will be the roots. For example, if I say 3 to power 5 over 7, directly say is equal to 3, here's denominator, so 7th root with the exponent of 5. And also, in the second part, you can write down like that. Or you can write like that. Why? Because we manipulate with the exponent. Look, zooming out to understand what I mean. You can manipulate. That's really the beautiful of math. Of all these rules, you can manipulate. If you have something like that, you can directly change it to that. And this is, you can do it by that. How? Because it's a denominator. Let me like that. Because you multiply, we have AMN, the third rule of the exponent. And also, by the third rule, we can do it like that. Because if you multiply, you get the same. If you multiply this one, or that one, or that one, all the other same. That's why I say I will leave the choice for you. You have many options here to deal with that examples. So I'm going to solve the example 10. Okay, example 10, page 16 in your lecture notes, part A. We have 4, 1, 2. So means that directly you can write down 4 is equal to 2. Okay, dear. How about B, part B? If you have 8, 2, 3, we can directly say AMN. You can directly say the denominator is going to here 8 to power 2, which is equal to, and you can play with it. You can directly say is equal to 8, 3, but let this one be like this form. I say is equal to like this form. I'll say is equal to 3. Why? Sorry, 2. Why? Because I know the cubic root of 2 is equal, 8 is equal to 2. So 2 by 2 is equal to 4 without using anything or any calculator. How about C? I will leave the C for you because it's very easy. There's nothing to be difficult here. We have negative exponent. We say the negative exponent to be any exponent should be go to the denominator, and we know how this one by the rules are equal by these rules are equal to what? Are equal to the cubic root of 1 over 3 is equal to what? Cubic root of 125, that's equal to 5. How about D? D the same is true. This one, forget about this one, is not true. Okay, you should leave it here because we don't need the negative exponent. That's why. Please try to solve 21, 23. Now example 11 in the same page. Look, it's the application of the rules. When I say application of the rules, I mean without memorizing your what do you say? Without memorizing your law, you can solve this one. Now, example 11. I'm going to solve B and D, and I will leave A and C because A is very important, easy, one step, and the third is like A and need more detail, need more working, so please do it. So I'm going to solve B and D. So example 11, page 16, part B. Say that if you have a 2, 5, A also 5 over 5, 7 over 5, A also 3 over 5. And do not forget about single base with positive exponents. So, in this example, I say what? Directly I say is equal, it's easy for me. Why? Because I say we have a 3, 5, let be a 3, 5, and a 2, 5, we add because of the same base. So the first First, what do you see? First rule of the exponent, same base, different exponent. So we'll add and. What is this? Forget about exponent. What is this? It's what? It's the case number 1 of what? Of two fraction with the same exponent. With the same, denominator. Look. Two fraction f1 plus f2 and the same case number 1. The same exponent. So I get what? The same denominator. I say is equal to a35. Okay, to be here. Now again I have what? Again I have a. So 2 is equal to 9 over 5. Now, by the other rule that we have, we say we should take the smallest or raise the smallest to the biggest exponent. So that's why I say a equal to 5, a to power minus 3, 5. As you know, 9 over 5 is greater than 3 over 5. Now I get what? Again, the same exponent and 5 minus 3, 5. What's this? So also again is the two fraction and subtraction between them, case number 1. So 9 minus 3 over 5 was equal to a 6 over 5. That's all we have here, and you can see the result. He did it really directly. I do for you because you need more things, that's why. D, part D, you have 2x 3 over 4, okay, all of them, the power 3, and y 1 over 3, again y to power 4, there's no exponent here, minus 1 over 2. So how we deal with that one? First of all, we distribute this exponent of the parenthesis, so I get 2 to power 3, x to power 3 over 4, all of them 3, y1 over 3, all of them over 3, and we have again y4, x to power what? Minus 1 over 2. We don't change anything because we need more steps here. So 2 to power 3 is equal to 8, and this one we multiplied is equal to x to power 9 over 4. I don't say why and how, and this one remains just y. Why? Because y, here I'll give you a note. Look, 1 over y, 1 over 3, all of them 3 is equal to what? You multiply 3 by 3. 3 by 3 is equal to 1. That's why I say it's equal to just 1. Now also I have a y to power 4, x to power 1 over 2. Why 1 over 2? Because this minus will go into up and it will be positive. So we change it to the positive. That's all we have. Okay. Okay, now what else? We bring this one to up because we need a single positive. So 8 x9 over 4 x1 over 2 y4 minus 1 directly, and I see is equal to 8. Do the math here, step, algebraic step. So this is the multiplication case, so I say plus 2. 2 fraction, case number 3. So try to review, and finally you get what? 8 x to power 11 over 4 y to power 3. That's all that you have, and I think here's the result and answer. Okay, dear. Now I'm going to solve example 12 for you, part A, and I'll leave this one as a homework. So you will see this one, these homeworks in your lecture, in your exam, okay, or in your assignments. So example 12, page 16, part A. 2 square root of x multiply by 3 cubic root of x. Okay, So how we solve this one? I think it's easy. We say is equal to 2 by 3 is equal to 6. Now we have x cubic root of x. We just multiply, eliminate the, because there's a multiplication, we eliminate the parentheses. Two parentheses, we have a couple of the parentheses, so we remove it. 2 by 3 is equal to 6, and this one remains. So how we deal with this one? We have in the first rule, we can do this one. In the first rule we have this one, or you can say we just multiply x by x3. Okay, so it's equal to what? Now I'm going to solve this one. Oh no, in your lecture note, solve it by the other idea. Now I'm solving by this one. Okay, so we cannot do it. Sorry. I thought this one's a 3. No, it's not 3. So we say is equal to x. This one will be x1 over 2. This one will be x1 over 3, because this we change it to the rational exponent, because they are different. The exponent are different, 2 and 3. That's why. So now I have the same base, different exponent by the first rule of exponent. We will change, and the by fraction case number 2. The case number 2, they are totally different. So we get what? 6, 5. That's all that you need. How we got this one? This is for f1 plus f2 case 3. You know what I mean. In the previous video you can find all these examples. Last page of this section, we have rationalizing denominator. How we get the same denominator. This example is also talking about rationalizing or getting the denominator. Now I have 2 over 3. Example 13 in page 17. We have a. So you see that we have 2 number 3. In your question, say what? What's the title of the question? The question say rationalize the denominator. Main denominator, as I told you, is the G record. A, B. We mean B here, denominator. Okay, in this denominator means that rationalize means that remove the square, remove the roots. Rationalizing means that remove the roots. Okay, so how we remove the roots, how we eliminate it, how we cancel it? So by something is not conjugate. When I say conjugate, means that owl. ضرب عوضيناك اللي بتكتشف. So it's not our conjugate. We just say we write this one. I need what here? We should multiply something the same, something box by box. So they should be the same, because we will multiply by 1. So which things I should put it here? Forgetting what? Forgetting number 3. You should tell me. I have square root of 3. So we should multiply by what? By the square root of 3. Why? Because this one by that one will be what? Will be 3 by 3. Am I right? And I'll get what? 3 square root. And we eliminate this one, then we get 3. That's it. So the denominator will remains, the numerator will remains the same. I know you don't understand, you don't get the idea. So I'm going to give you another example, or we are going to solve part B, because really I know you don't get this one by one example. Part B, the same example. We have now pay attention what I have. I have x squared and I have a cubic root. So between this power and that root, it remains how many? Just tell me. How many x remains? You tell me. Sorry. Between, now I'm writing 3, I'm waiting for an answer. Between this and that, how many unit remains? How many number? How many digit? just 1. Am I right? So I have 2, we should multiply by 1. That's why we add this one. Now I am changing my question. Or let me solve this one, then later I will change the question. So we say what? We say 1 by cubic root of x, it remains cubic root of x. Now this one, it remains just x. Why? Because if you multiply this one, you get 3x squared by 1x. Now I will get x3 cubic root by 3, and it just remains x. That's why we did like that. Now I'll play with this example. Just example B, part B, I will play with it. If I have, I'm asking you, if I have something like that, so I should multiply by what for getting x? Surely you have cubic, so I should multiply by what? I have 1 on here, so here should be what? X or x squared? Yes, x squared. Why? Because here just 1x, so 1, 2, 3, I need 2 units, so that's why I multiply by 2. So 2 by 1 is equal to 3 by 3. That's why we multiplied by cubic. And this one will remove. Then we rationalize the denominator, just x remains. That's why we say rationalize the denominator. Okay. Now for the part C, I know you got the idea now. We have 7a squared. Okay. Now you tell me, between 2 and 7, how many a remains? I put the 7th root. So how many a remains? You should say between 2 and 7, I need 5. So that's why we multiplied by 5, because later I will get a7, 7, and this one multiply, and this one multiply by this one, nothing else. So we removed a as a rationalizing denominator. Okay, dear, that's all that you need. Try to solve 89 and 91. Really, as I told you, 1.1 till 1.4 is like a recovering, backupping, reviewing your background in math. That's why I say we call it algebra, especially from 1.1 to 1.4 is the fundamental, basic, and review. Okay, that's it. That's all that you need in this section. I hope you got. Don't be tired. Try to be with me in this.